can also be sharing it so that each and every one of us can be able to understand or to get what we have been doing. So let us get started without wasting any time. The goal of our today's class is to basically now start understand what is testing. Last week we were able to introduce what software testing and quality assurance is all about, why we need it. Now today we are going to the specifics or to the specific terms so that we can understand what we mean when we talk about software testing. And the first thing we might need to understand, or the first question that we need maybe to ask ourselves, is what is the role of testing? Because it is very important to understand why are we doing testing in these software systems. Because when we are testing, we are just trying to understand. We are trying to understand if the system is working with or is working as expected. So why do we need to do the testing? Yes, we know the reason is to check whether the system is working, but at the same time, we need to understand its role in detail. So when we are doing testing or when we are testing software, is so that we can achieve or acquire the standard or the quality standard of that software product. Like we had said, there are several perspectives to software testing and quality. So when we are doing testing, we want to ensure that we have achieved that specific standard that is expected, whether it is from the user perspective, whether it is from the industry perspective, whether it is from the developer's perspective or a cost perspective. The reason why we are doing testing is to ensure that we have achieved that specified standard. So that is why we do testing. Now, we also do testing so that we can improve the quality of that product. So the first one is to acquire the standard. That is the first role. The second role is to ensure that we can improve the quality of the product. So that is the second reason why we are doing testing, so that we can improve the quality of that product, and it will be achieved, or the improvement will be achieved by the process of testing. Then you find defect, and then you fix. So there is that cycle you will follow of testing, finding defect, and then you fix. Once you fix, you start again to test until you have achieved that quality standard you are looking for. So when we are talking about software testing, it will be that verification process. But we have said it serves those two roles. So by definition, we are saying it is that process of evaluating the system or its components so that it can find whether it has satisfied the specified requirements or not. So that is one of the reasons, and that is why we are talking about meeting the required standards. Then the other one we have said is to check if there are any defects. And when you come across any defect, you will fix it, and then you continue with checking again, so that at the end of the day, you have achieved the required standard. So basically, that is what we mean by testing. Now, that testing process is an activity which results in the actual or expected, and difference between their results. So when you do the first test, you will get a certain result. You go again, fix where the problem is, then you test again, you will get a different result until you have gotten the actual or the expected result. Then you can say that you have tested the system and you feel that it is fit for use or it has accomplished the required expected outcome. So that is what we normally mean by testing. So in simple words, or basically, we are saying that it is executing the system in order to identify if there are any gaps. That is why we were saying the second role is to check for any errors, and then you correct those errors. And once you correct them, you fix them. So we are saying it also checks if there are any missing requirements. That is why we are talking about either to identify any gap or to check for any error. And once you have checked for the error, you also check if there are missing requirements. So during the requirement capture, you always check what is expected for the system. And once you have checked what is expected for the system, you will go on to develop the system. And when you have developed the system, you will come back and check if you have met those requirements. So when you are checking whether you have met those requirements, it is also a process of testing. And once you have done that, then now you can say you are developing the system according to the requirements. So according to ANSI IEEE, so this ANSI stands for the American National Standards Institute, and IEEE stands for the Institute of Electrical and Electronic Engineers. And these are bodies which come up with standards that can be used to check for systems, or they can be used to test for systems. And according to this standard 1059, it defines testing as a process of analyzing a software item to detect the differences between existing and required conditions. So, like we were defining last week, we were saying that there is that expected output and there is the actual output. So, when you check against the two, that the actual against the expected or against the standard, then you can be able to tell whether that software object has achieved its required expectation or it has not achieved its required expectation, and then you can say whether it is of quality or not of quality. So here, when we are talking about the required conditions, we are checking it against if it has any defects, errors, or bugs. And its purpose is to evaluate the features of that software item. So it is a process of analyzing a software item to detect the differences between existing and required conditions to evaluate the features of that software system. So who does the software testing, or who tests this system? Number one, we normally have the software tester. We also have the software developer, the project manager, and the end user. These testers, or these people involved in the testing process, they will be either at this level of unit testing, or at this level of integration testing, or at this level of system testing. When you are doing system testing, most likely you will be the software tester and the software developer. And when we are talking about unit testing, something we will discuss later, you're just looking at a specific component of the system and you're trying to see whether it is working as expected. Let me give an example. If you are developing a software for a university or a student management software, or it is a software for a manufacturing company, then there will be several modules. Let's talk of this student management software. You can have the admissions module, you can have the exams module, you can have the finance module, and you can also have the requisitions module. So each module will be tested as a unit. If it is students admission, you will test that as a unit to check whether it is able to admit students as expected. The exams module will be tested as a unit to check whether it is able to examine students, it is able to capture marks and be able to compute the grade of that student and may be able to rank the students in a class. So that is what we call unit testing, checking each module whether it is performing as expected, and then we go to integration. At the integration level, you're trying to see if those units, when they are combined, they can be able to give the expected result. At the end of the day, you want the system to be able to exchange information, for the system to be able to give you consolidated reports. So for example, you would want the system to be able to evaluate the student on the basis that they have cleared the fees. So the financial module is required. At the same time, they need to have been able, they need to have done the exam. So the exam module is required so that you can get a comprehensive report. So at the integration level, or when you are doing integration testing, you are checking whether these two modules are able to exchange information and they are able to integrate to give you a consolidated report that is able to tell you whether you have given, the system is able to exchange information. And then the system testing is where the user comes in. The user doesn't need to know what is happening at the back end. The user needs to see the results of what they are looking for. So the technical capabilities of the system will not be of any use to the user. He just needs to be able to see that the system is able to give the results that are needed. And that is where we are talking about these users at those different levels. Then, when do we start testing? After we have looked at those people who are doing the testing, when do we start testing? Testing will begin as early as possible. From the moment we are collecting the requirements, that is the time we normally start testing the system. So in order to reduce the costs and the time to rework and correct errors, then we need to start the software testing as early as possible. And that is where we are talking about in the software development lifecycle. Testing normally begins when we are gathering requirements. That is when we start now checking whether we have gotten the right requirements. That is why we normally have the requirements specification document, which after the user has given you, as the software developer, after the user has given you the requirements, then you will need to go and check whether those requirements are correct. You list them down and then you bring them back to the user and ask them or let them verify whether these requirements are the right ones. And once they have verified that these are the right requirements, then now you can go on to start analyzing them, and then you start designing the system, then you go on to develop or code the system and test it. So testing begins from that moment when we have started collecting requirements, and it will last till you have deployed the software. When we talk about deployment of the software, is handing it over to the user and commissioning it for use, or training the user on how to use it, and also making sure that it has started working. That is what we mean by deployment. So we are also saying, as much as it begins from requirements gathering, we are also saying that it will depend on the development model which you are using. There are different software development methods which are normally put into use. So you can have the waterfall development method, you can have the spiral software development method, you can have the rapid application development method, you can have the prototyping development method. All of those are different methods of developing the software. And each one of those methods can always have different model of how you are going to capture those requirements or how you are going to test that software. So in the waterfall model, for example, here we are saying that formal testing will be conducted in the testing phase, meaning that you will have already collected the requirements, you will have already designed the system, you will have already developed or coded the system, and then testing will come immediately after you have coded the system. Now compare that with an iterative model or incremental model like rapid application development or joint application development or prototyping method, which now does the testing as you are capturing the requirements, and testing keeps on being repeated until you have deployed the system. So testing will be done in different forms at each phase of the SDLC, like during requirements gathering, also at the analysis stage, and also at the verification stage of the requirements. So all of those will be considered as testing so that you can be able to have the right requirements, because if you don't get the right requirements, it is most likely that you are going to develop the wrong software and acceptance to the user will be a challenge. So that is how we normally start. That is why we normally start testing at the requirements stage. Again, when do we stop testing? You can stop testing once you are sure that the system is working 100%, which is something that is very difficult. So testing can stop when there is a deadline. You can always put a deadline when to start and when to stop testing, or when you have completed the test execution process, or when you have captured all the functional requirements of the system and at a certain point you feel that you have covered all the requirements. Also, if the bug rate falls at below a certain level, if the system had errors and you feel that you have sorted all those problems to a certain level, then you can feel that this system is good for deployment, then you can stop testing. Or if a management decision has been arrived at and you feel that this one is ready for deployment, then you can stop testing. Now, testing is normally carried out in two forms, whereby we can have it as either verification or as validation. So these two terms, sometimes they are used interchangeably, but they mean different. When you are talking about verification, you are asking whether you are building it right or whether you are following the right process to build that software. Validation is checking whether you are building the right software. So when you are verifying or when you are trying to check whether you have the right requirements, that is actually a process of validation. When you are testing whether you have done the system or whether the system has errors, that is a process of verification. So that is why we say verification is that process which ensures that the software system is meeting the required functionality. On the other hand, when you are checking whether the functionalities are meeting the required behavior, then that is validation. And here, the validation will be done either by the project manager or by the user, depending on the software development methodology that you are using. Also, verification will be taking place first, and it will include checking for documentation and the code when you have developed the system or when you have coded the system, while validation will come after verification has been done and you're just checking at the overall product, and this is normally again by the user or the project manager just to check whether it is doing the right thing. Verification is done by developers because it will include checking the code, but validation will be done by testers, that is like a project manager or a user, just to check whether the system is doing the right thing or is doing the what is it is expected to do. When you are doing verification, again, you perform some static activities like reviews, walkthroughs, and inspections. But when you are doing validation, it will involve dynamic activities that include executing the software to check it against the set requirements. Again, when you are doing verification, it is an objective process, not subjective, meaning that there is the objective which you want to check against, but when you are doing validation, you are performing a subjective process which is trying to check whether the system is working or not. So those are the differences between verification and validation. And then before we go to checking the difference between testing and quality assurance, now let me go back to the presentation which I needed us to look at. So this is what we needed to look. We have already looked at the role of testing and we have understood why we need to be doing software testing. Now, let us now proceed to look at these processes which are normally carried out in testing. We normally do testing as a static analysis and also as a dynamic analysis process. How is that done? When we are looking at a static analysis, we are doing what we are calling verification, like we have already seen. And this static, it suggests that it is based on the examination of a number of documents, meaning we are looking at the requirements document, software models, design documents, and the source code. That is why it is a static process, because we are checking against some documentation which is not going to be changing until some decision has been made for a change. So the traditional static analysis will include code review, inspection, a walkthrough, algorithm analysis, and proof of correctness. Now, when we are doing code review, we are checking this code or the development code against some coding standard. If you are talking about procedural coding, then you are checking against those standards. If you are talking about object-oriented coding, you are checking against those standards. So when we are doing code review, we are looking at that design of the code to see if it has met those standards. If it is object-oriented programming, it has its own standards and you need to check against those standards. When we are doing inspection, we are just looking at whether the code has been done right. Is it following the order of the requirements? That is what we are talking about inspection. Walkthrough is just going through the code to see if it has captured everything according to the standards that or to the requirements that have been given. And then algorithm analysis is just looking at the code and seeing if the code has implemented the algorithms as required. When we talk of an algorithm, is that step-by-step process of solving a particular problem. Now, let us go back to that example of a student management software, whereby we said it has the examination module. Now, in the examination module, there will be an algorithm maybe for adding. There will be a formula for adding marks for the coursework or the CAT and the exam. So we are checking whether that algorithm is working right. Are you adding those marks right? So that you can be able to get the total marks and then you can be able to get the grade. So there will be an algorithm of adding the marks to get the total and then checking against maybe a grading standard so that you can be able to tell whether this is an A grade, a B grade, and so on. So that is what we mean by an algorithm analysis. Just looking at that algorithm and the way it has been coded to see if it is okay. And that is closely tied together with the proof of correctness. So once you have checked the algorithm, you can be able to tell that the algorithm is working right or not. So that static analysis, it does not involve the actual execution of the code under the development. It is just examining the code and reasons of all possible behaviors that may arise during runtime. So you are just looking at the code to see if it is working right, just by looking at it, and that you can, and you see if you can be able to identify any error or any challenge that may arise during the execution of that code. And that is what we mean by static analysis. Then we go to dynamic analysis, whereby now the software system is going to be executed so that you can expose any error or any failure in that program that you have coded. That is what we mean by dynamic analysis. So here we are looking at the behavioral attributes and performance properties of the programs so that we can be able to tell whether it is working as expected. How is it behaving and how is it performing? Those are the questions we are asking from the dynamic analysis. So here we are going to execute the code and check at the output that it is giving against the input values so that we can be able to tell if it is a calculator program we are doing. If you input two numbers, are they going to be added properly so that they can give the right output? Because it may give an output which is correct, but the way the computing has been done is incorrect. So that is what we are checking against. So for practical considerations, we are going to have a finite number of subsets of inputs that can be selected. So we can have some random numbers which we are trying to input into the system and check whether they are working as expected. So when we are doing this dynamic analysis, when we are talking about testing, we are observing some representation of the program. And once we look at that representative program, then we can check the behavior and reach a conclusion about the quality of the system. So that is what we mean by dynamic analysis. And we have already seen what verification is. Verification is the static analysis, and then validation is the dynamic analysis, where we are doing the actual execution of the project. So we have already explained what it is. When we talk about verification, we are just talking about the process that establishes the correspondence of an implementation phase of the software development process with its specification. And we are saying that the verification activities aim at confirming that one is building the product correctly. So we are looking at the process basically if we are doing it correctly. When we are doing verification, activities will include the requirement specification. We'll be looking at the requirements specification, the design of the system, the code, and the user manual. And when we are looking at these, we will go through several stages of the software development life cycle, whereby we will be talking about the requirements specification. That is one of the stages. The design is another stage, coding is another stage, and the user manual is another stage altogether, whereby you are trying to develop a documentation which can be used by the user to follow through when they are implementing the system. So the quality attributes are sought for each of those stages to ensure that they are working as expected. Verification activities are also performed on interim products, meaning that you will not, when you are verifying, it's not like you have the final product, but it is the interim product. Like at the design stage, you don't have any product at all, but you have the design of the product. and then at the coding stage, you don't have the final product, but you have maybe a prototype or a framework of the final product. And then that is why we are applying the static analysis techniques such as inspection, walkthroughs, reviews, just to check what we are doing is right. Then we go on to the verification again, and to say that these activities which we are performing at these stages, they are trying to help us confirm that the product is meeting its intended use. It is not okay to develop the product until the final stage and then you start checking whether it is meeting its intended use. You will have done a lot of work for nothing, and that is why these iterative development methodologies are mostly preferred, because they will help you check as you are developing so that you know you are on the right track. The validation activities aim at confirming that the product is meeting its customer's expectation. And in other words, we are saying that we are looking, these activities are focusing on the final product, which is extensively tested from the customer's point of view. And when we are looking at validation, we are establishing that the product is meeting its overall expectation, and the user will be satisfied when they are using the product or when they are actually executing the software program as it were. Validation will also establish the correspondence between the user and the system. So the user will have some expectation in mind, or they will be checking against the requirements that they give, and the system will also be having some standard to which it needs to meet. So that is where the correspondence comes in. And when we are looking at the correspondence, we are just trying to confirm that one is building the correct product, and the end product is meeting the customer's needs and expectation. So validation, unlike verification, which was being performed at each stage of the system development, validation is performed on the entire system, and it is actually performed during the runtime, or it is performed in the real environment where the system is being used. So that is the difference between verification and validation. Then let us look at these terminologies which are normally used during verification and validation. Normally talk of a failure, an error, a fault, and a defect. So these ones, they can be used interchangeably, but they have different meanings. So when we are talking about a failure, we are saying that it occurs whenever the external behavior of the system does not conform to the prescribed behavior in the system specification. If you had said that my calculator system should be able to add two numbers and give the output or give the result, and then when you add these two numbers, it gives you an error, then that is a failure, because the system does not conform to the expected behavior which you had in mind. So that becomes a failure. When we talk of an error, it is a state of the system. The system may give you the results that you needed, but it may have an error within itself. So that is something I need you to note, that in the absence of any corrective action by the system, an error could lead to a failure which would not have been attributed to any event or subsequent to the error. What we mean by that is that an error may occur whereby the system is able to add the two numbers, it is able to give you the result that you needed, but not in the format that you needed. So that could tell you that there is an error. If this error is not worked on, at the end of the day, it will give you a failure in the system. Now, a fault is the adjudged cause of an error. A fault is that aspect of the system, or it is that component in the system which is causing an error to occur. So it could be maybe a fault, it could be a problem with the algorithm, with the solution giving process which occurs in the system. And those are the differences between these three terminologies, whereby we say that a fault could be in the algorithm when we are talking about in the formula that is supposed to give you the answer you are looking for. And then an error could occur whether the system is performing as expected or not. When the system does not perform as expected, then it causes a failure. So we normally start with a fault. A fault leads to an error, and an error leads to a failure. Then we move on. A fault may remain undetected for a long time until some event activates it, because you may not have noticed that your formula has a problem until you start calculating the numbers, then there is a problem. When an event activates the fault, then it brings the program into an intermediate error state. When we are talking about an intermediate error state, is that state whereby it is still performing, but it has not gone on to a failure. So if a computation, here is an example, if a computation is allowed to proceed from an error state without any corrective action, then the program eventually causes a failure. So you could find a system being fault tolerant, meaning that corrective actions can be taken to take a program out of an error state into a desirable state such that subsequent computation does not eventually lead to a failure. The process of a failure manifestation can therefore be succinctly represented as a behavior chain as follows, whereby we start with a fault, then the fault will lead to an error, and that error leads to a failure. Now, that behavior chain can iterate for a while until the system is not able to perform at all. So, when we talk about software reliability, what exactly do we mean? Or when we are talking about the software being reliable or being able to be used even when there are errors and faults. It means that no matter how many times we run the test, find, and fix cycle during software development, some faults can escape our attention, and then these will come up at the customer site or will come up when the system has been deployed. So when we talk about the system being reliable, it means that the probability of having a failure-free operation of the software is very high until some activity triggers an error to occur. So we are saying that this system is reliable in a sense that it is able to work without showing any error for some time, and during this time there is a fault inside the system, but it has gone undetected until a trigger happens and then that error shows up. So the level of the reliability of the system depends on those inputs that cause failures to be observed by the end users. So this will happen at the end user site when the system is in execution. That is what we mean by the system being reliable. So this idea of reliability is specific to a specified environment, meaning that in a certain environment, the system can work without any problem, and then in another environment, the system will be exposed to some triggers which now will be able to show those errors which were had run undetected. That is what it means. So, what are the objectives of testing? The stakeholders, those guys we had identified, either the developers, the testers, the users, the managers, those are the stakeholders we are talking about here, are normally there to ensure that the system is working as expected. So a stakeholder is any person who has influence or whom the system has influence in a way or another, or the system has an impact on them in one way or another. So that is the person we will call a stakeholder. And different stakeholders will view the test process from different perspectives. So one stakeholder will be asking whether the system is working. And this stakeholder will be looking at the system from a program unit or a system unit. So that person will be either a developer or a tester, and is the one who is asking, does it work? Then there is another one who will be asking, why does it not work? Or why is it not working as expected? And this one will be looking at the system from a functional viewpoint. This is the user or this is the manager who will be checking the system as a whole and will be trying to look for any fault or any error during the system runtime. So that is why we look at the objective of testing from those two perspectives, from the developer's perspective and from the user's perspective. The developer will be asking, is the system working? The user, or from this other perspective, will be asking, why is the system not working as expected? So the reason why we are looking, or the objective, first of all, from the developer's perspective, is to reduce the risk of failure. Or when we are looking at the developer's perspective, we are checking that the system does not fail from time to time. Or when the system has gone to the user, it will not fail during execution. So we are trying to reduce the failure rate. When we look at the user's perspective or from the manager's perspective, is to reduce the cost of testing, because tests are going to be different. The cost of designing, the cost of maintaining, the cost of executing test cases. There will be also the cost of analyzing the result of executing such a test system or such a test case, and the cost of documenting the test cases, as well as the cost of actually executing the system and documenting it. So that is why we are looking at the testing at the user's perspective to reduce the cost of testing. Because once the system has landed into the user's hands or the manager's hands, then you need to ensure that it runs as expected during the first time you are testing, and you don't need to keep on going back to correcting errors and coming back again. So when we are looking at the testing activities, we normally look at them from computation, that is, select a specific output, a specific input and the expected output, then you run the test. Once you have run the test, you will come down to result analysis. That is the first activity. The second one is you select an input, put it into a specific environment. This one was at the developer's site. This one is at the specific environment or the environment where the system will be working, and then you observe the actual outcome, analyze the test, and then you can have a verdict at the end of the day. So those are the testing activities we normally perform. So when you are performing these activities, there is that process that you will follow. The first activity in the testing process will be identify the objective. Why do you want to perform the test? So the first activity is to get the objective or the intention or the purpose. And when you are doing this, or when you are trying to get the objective, is so that you can design a test case that will ensure the program will support that objective. So if, for example, you want to tell that the system is giving you correctness, then you will develop a test case that will determine whether the system is giving you the correct output. Sometimes you want to test the performance speed. So you will develop a test case that will be able to give you the performance in terms of speed. Sometimes you want to test the maintainability. So you will develop a test case that will be able to give you the objective of looking for maintainability in that system, and we will look at those. So that is why we are trying to come up with the purpose. What is the purpose of this test you are performing? Then once you have come up with the purpose, then you are going to select inputs which are going to support that purpose. And these inputs will be based on the requirements specification, and they will also be looking at the source code and our expectations. Then after that stage of selecting the inputs, you will go to the third stage of computing the expected outcome. So on the side, you will determine if it is a test case of adding two numbers to test the correctness, you will already have the result. What is the addition of 5 plus 5? It is 10. So you already have the 10 on the side, and then you input those two numbers into the system and try to see if you are still going to get the same outcome as you had gotten it manually. So if the system is able to compute that, then you are able to say that you have accomplished. So the third stage is computing the expected outcome. Then you go to the fourth stage where you are setting up the environment of the program. And here you are setting up the environment so that it can give you the expected outcome. Because if you tested the system under development, it can give you the answer. But once you have deployed the system, then it is not able to give you the answer it was giving you. That is why you have to move that system from the test environment or the development environment into the actual execution environment. That is why we are talking about initializing the local system external to the program, and then you also initialize the remote system, which is also partnering or which is also connected to the other support system it will be working with. Once you have set up the environment, the next stage is to execute the program. You actually execute the program, and here it is the test engineer who is executing the program with the selected inputs, and then you observe the actual outcome of the program. So to execute the test case, inputs may be provided to the program at different physical locations at different times. So that is where the concept of test coordination comes in, so that you can have what we call synchronization. By talking about synchronization is looking at this system, how it is performing in those different test environments. Then after executing the program, you can analyze the results. And this is the final test activity whereby you are looking at the results of that execution. So here, the main task is to compare the actual outcome of the program execution with the expected outcome. If, for example, you are testing the speed in terms of performance, you know that the normal execution should maybe take 2 microseconds. Then you check, how did my program perform against those 2 microseconds? Maybe it took 1 microsecond, which means that it has performed exceedingly well, or it took 4 microseconds, which means that it has taken longer and it is not performing as expected. So here it is an example like the observed data type can be as simple as an integer or a string of characters, or as complex as an image or a video or an audio clip which is being executed. So at the end of the analysis step, a test verdict will be assigned to the program whether it has passed, it has failed, or it is inconclusive. When we are talking about an inconclusive output, is whereby the program produces the expected outcome and the purpose of the test case is satisfied. So that is a pass verdict. Or the program does not produce the expected outcome, then a fail verdict is assigned. However, in some test cases, we can have some results which are inconclusive. So it is very likely that you will get some inconclusive results. After you have performed the test and you have seen the results and you can analyze them, you need to prepare a test report, which now is done after analyzing the test result. And this test result is important so that you can get to fix that fault, and then you can be able now to improve the quality of that system software. So in the test report, you have to include details of how to reproduce the failure, how to analyze the failure and be able to describe it. And at the end of it all, you can point to the actual outcome and the test case, complete with the input, expected outcome, and the execution environment. So that if somebody wanted to do it later, they can be able to do it. Then, when you are performing these tests, there are some specific levels you normally do them. So we start with unit testing, and with unit testing, like I had explained, it is normally performed during coding, and you test specific modules or components or unit of the entire system to see if they are performing as expected. Then after that, we normally perform integration testing, whereby you are integrating or you are combining those components, then you test them as one to see if they are able to communicate with each other, they are able to exchange data and produce reports as expected. Then system testing is usually performed as a whole system to test the performance and production of any errors at the high level design of the system. And then there is acceptance testing, which is like a validation process, and this is normally performed by the user to see whether they accept the system the way it is performing or not. So those are the different levels of the system testing, and they have been explained here. So the first three levels, that is unit, integration, and system, they are performed by a number of different stakeholders in the development organization, whereas acceptance testing is performed by the customer to tell whether the system is performing as expected. And these four stages have been illustrated in the form of the diagram, which we call the V model. So when somebody will ask you in the exam to explain the V model of testing, then you will understand that it is this diagram we are talking about, which starts with unit, goes to integration, then system, and then acceptance testing. So in unit testing, it is programmers who are testing the individual program units, such as procedures, functions, methods, and classes in isolation. Then, after ensuring that these individual units are working to a satisfactory level, then those modules are assembled together to construct larger subsystems by following the integration testing techniques. Integration testing is normally performed by software developers so that they can be able to tell whether the system is properly integrated or whether the system is working as a unit. The purpose of integration testing is to construct a reasonably stable system that can withstand the rigor of level system testing. And then we go to the system level testing, which includes now a wide spectrum of testing, such as functionalities testing, security testing, robustness, load testing, stability testing, stress testing, performance testing, and reliability testing. We shall go through these different levels of tests in the future as we continue, but they are normally performed at the system level testing stage. Then after that, we do a regression testing. Now, a regression testing is normally a combination of those three levels of system which create like a cycle. So that cycle is normally at the developer's end, whereby you are able to do unit integration and system testing. And if there is any kind of a problem, then you can go back again, correct it, and keep on doing it like that. And it has been summarized here. So you do unit, you integrate, and you do system testing. If there is any problem, you regress. That is why it is called regression testing. You regress, correct any problem that is there, and start again at unit testing, integration, and system testing until you are sure that the system is performing at a reasonable, acceptable level. Then now we can go to acceptance testing. When we are talking about acceptance testing, we are looking at the customer here who is performing the testing itself. And here is to measure the quality of the product rather than searching for any defect, which is the objective of system testing. So in acceptance testing, we are looking at the customer's expectations from the system. So by the time of acceptance testing, the system should have developed their acceptance, the customer should have developed their own acceptance criteria from their own expectation from the system. And here we look at the two types of testing. One is user acceptance testing and business acceptance testing. When we are talking about user acceptance testing, it is conducted by the customer to ensure that the system satisfies the contractual acceptance criteria before being signed off as meeting user needs. Then business acceptance testing is undertaken within the supplier's environment or during deployment when you go to deploy it, to deploy the system where it will be working. Then you normally perform the business acceptance testing to see if it has passed the user acceptance tests. And those are the levels of testing which are normally performed. So thank you for your time and for listening to this class up to now.